And welcome again. This is one better problem. If as far as last few problems has been solved, it's a bit better. The problem statement is the circuit consists of a source with EMF Xi equals 100 volt. This source, I guess, two identical capacitors with a capacity of 10 microfarad each. Okay, and the key is here. First, one of the capacitors was charged to a voltage of U1 equals 200 volt. This was charged initially, and the second was not charged. How much heat will be released when the key is closed? Okay, so key is being closed. The battery is here, and key has been closed. So we have two capacitors. Left one is C1 and right one is C2, though C1 equal to C2 equals C is provided in the problem. And it seems at the very first glance, this system looks like two capacitors are connected in series and connected to a source. However, this is not the case, since one of the capacitor was charged before closing the circuit, and then after closing, the charges on the capacitors are not equal to each other, so they are not in series. We need to calculate the final voltages, so we will need to write two equations in such conditions. And we will use first the law of conservation of charge, and we know what will happen. So I just concern the figure of the problem and give them charges like this, and their potentials must have been changed after the switch being closed. So its potential difference becomes U1 dash and its potential difference becomes U2 dash right now. And we are going to write the conservation of charge or first circuit equation. That is, if we start from here, give it a zero potential, although I don't need to give it, but give it a zero potential. We move from this part and reaching here, we are going to gain, since we have moved from lower to higher potential regions, so we have gained a potential E. Then we move from here to here and lost the potential U1 dash. Lost the potential U1 dash. And then in moving here, no loss, no gain, and then we can gain here. That is U2 dash and reached again to 0. So the thing is now clear that we have a circuit equation like E equals U1 dash minus U2 dash. This is our equation. This is the circuit equation, but now we need to write down the law of conservation of charge, and so I can write here final charges being C1 U1 dash and C2 U2 dash, and this must be equal to C1 U1. This is our equation 2, and this is the clear-cut equation of conservation of charge. And now we need to find out U1 dash and U2 dash. As I calculated earlier, and you can calculate it too, U1 dash will come out simply like C1 U1 plus C2 E divided by C1 plus C2. That is simply U1 plus E divided by 2. Yeah, of course. and you can find U2 dash as C1 U1 minus C1 E divided by C1 plus C2, and the similar manner you will get it as U1 minus E by 2. So U1 dash and U2 dash is being found out. We need to find the charge that passed through the source. So after the switch being closed, source has sent a charge U2 C2 U2 dash in this direction to this capacitor, but we need to take the charge in this direction. So the work done by the source, first I need to find out the charge passed through the source, and in this case this is we usually write it as delta Q. So this is basically the charge passed through the source in positive direction, and this will be minus C2 U2 dash. You need to calculate it, and I can it's in terms of C1 C2, it is C1 C2 E minus U1 by C1 plus C2. That you can write C1 equal to C2, so you can write C2 C by 2 E minus U1, and work done by the source, that is work done by the external agent, in this case will be delta Q multiplied by EMF of the source, and you will get finally calculating it C1 U1 dash square by 2 plus C2 no, you can calculate the work done by external force simply here like this, and use the result, law of conservation of energy directly, and that is work done by external force equal to change in potential energy plus heat released, and work done by external agent is simply C2 E minus U1 multiplied by E, and our final potential energy is C1 half C1 U1 dash square plus half C2 U2 dash square, and initial potential energy was half C1 U1 square and plus Q, and you are going to get the amount of heat released. That will come out as C E minus U1 whole square divided by 4, and that's all. You need to take the steps, and remember one thing: if a capacitor is charged already and we connect another capacitor to it like this, they are never in series. Thank you very much for watching. Go through the normal processes and solve them.